Hey guys, in this video I'm going to discuss a discrete random variable. Discrete random variables, they have countable numbers of possible values. That means they don't go on and on. The probability of each value of a discrete random variable is between 0 and 1, and their sum has to add up to 1. So in this example here, I said let x represent the number of pets a person in the city owns. In the city, a person can either own no pets, 1, 2, 3, or 4 pets. But let's just say there was a city code that said no one can own more than 4 pets. Well, this is what we call a probability distribution table. It gives you the way the probability is distributed for each possible scenario or each possible case. So the probability that someone owns 0 pets is 0.4. And the probability that someone owns 1 pet is 0.1. And the probability that someone owns 2 pets is 0.2. The probability that someone owns 3 pets is 0.2. So my first question is, what's the probability that someone owns 4 pets? Well, we said that the probability must add up to 1. So this is 4, 5, 6, 7, 8, 9. And then we're just missing 0.1. What's the probability that x is less than 2? Well, less than 2 means the probability that x equals 0 or probability that x is 1. In mathematics or in probability, or means to add. So the probability of x equal 1 is 0.4, and the probability of the probability that x equals 0 is 0.4, and the probability that x equals 1 is 0.1. So there's about a 50% chance that someone owns less than 2 pets. Well, what's the probability that someone owns 2 or less? Well, in this case, it's just like the previous problem, but we're just going to have to add one more probability, and that's 2. And we're going to get 0.4 plus 0.1 plus 0.2, and that's going to give us 0.7. Now, that's basically a probability distribution table. Here's a really interesting question. How many pets does the person own on average? How many pets does the person own on average? Well, before I take a look at that question, let us take a look at another example. Here, I let x represent some numbers, 4, 8, 12, and 16. They represent something. I don't know what they represent, but they're just something. If I asked you to find the average, you would just take 4 plus 8 plus 12 plus 16, add them up to get 40, and then divide by 4. So our average is 10. We were able to do it this way because each piece had the same likelihood of happening. So each was worth exactly the same probability. So in other words, if I wrote it as a probability distribution table, I would write down 4, 8, 12, 16, and each piece has a 0.25 chance of happening. So in this case here, if I wanted to find the average, first I'm going to represent it by e of x for the expected value. You should know that. But in order to find the average or the expected value, I'm going to call this mu of x. They all mean the same thing. Mu means that you have the population, and you know you have the population because it adds up to 1. But in order to do this, I'm going to do 4 times 0.25 plus 8 times 0.25 plus 12 times 0.25 plus 16 times 0.25. And if you know quarters, then you know 4 quarters is equal to $1, 8 quarters is $2, 12 quarters is $3, and 16 quarters is $4. 1 plus 2 is 3, 3 and 3 is 6, 6 and 4 makes 10, and then you notice that we get the same exact value whether we add them all up and divide by 4 or if we multiply them by its probability of 0.25. So you might be asking, how come we don't just add up the numbers and divide for all of them in order to find the average? Well, that's because not all of the numbers have the same likelihood of happening. Let's say that X represents the number of shirts a person buys from a really expensive store. Well, in this case, in order to find the average number of shirts, what is the average number of shirts? Well, a person that we expect, the average number of shirts we expect a person to purchase. Well, we're going to follow the same rules as the previous problem. E of x, which is also mu of x, is equal to 0 times 0.5 plus 1 times 0.4 plus 2 times 0.1. So all I got to do is take this number and times it by this number, and this number times this number, and this number times this number. And mu of x, which is equal to E of x, is equal to 0 plus 0.4 plus 0.2. So we expect, on average, that each person buys 0.6 of a shirt. Now, most of you might say, how could somebody buy 0.6 of a shirt? Well, 5 people are expected to buy none. If you take a look at what this really means, 5 people are expected to buy none, because 0.5. 4 people are expected to buy 1 shirt, and 1 person is expected to buy 2 shirts. So in other words, in 10 people, if 10 people walked into the store, 5 of them will buy 0, 4 of them will buy 1, and 1 of them will buy 2. And if you found the average of this, then you would understand that that number is equal to 0.6. So do not round up. The answer is 0.6, and that's pretty much how you find the average. So to go back to our original problem, what's the number of pets that a person owns on average? Let's try this last problem. Well, E of x, which is equal to mu of x, is equal to 0 times 0.4 plus 1 times 0.1 plus 2 times 0.2 plus 3 times 0.2 plus 4 times 0.1. And that's how you find your expected value. So tune in for the next video where I take this even further and we discuss the standard deviation.